In section 1.5, we're going to talk about division of segments and angles. We are going to start with the first definition of a midpoint, which is a point that divides a segment into two congruent parts. Although the definition states it as a point, it also refers to a segment, ray, or line that could divide a segment as well. Let's take a look at three quick diagrams. One of a line, one of a ray, and finally one is a line segment, all of which have X in the middle. And the question I ask is, can X be the midpoint of these diagrams? If we look at the first one, the line, X cannot be the midpoint of a line because a line does not have a start or a beginning. Therefore, the middle point would be arbitrary because it has no ending. So it would never be a midpoint. The same goes for a ray, because in this case, the ray does not end anywhere to the right. You cannot pinpoint where a midpoint would be. Therefore, X could never be the midpoint. And finally, in the third, X appears to be the midpoint of this line segment because these two segments appear to be congruent. But since the diagram isn't clearly marked as these to be congruent segments, we have to say sometimes. In the first example, we're given if line segment MN bisects line segment OP at Q. We're asked a couple of questions. Is PQ congruent to QO? And is MQ congruent to QN? Because of the wording of the statement that MN bisects OP, OP is the one being bisected. Therefore, we can mark the diagram to show that OQ and QP are in fact congruent. Therefore, yes, this first one will be congruent, and that would be always. The second question asks about MQ being congruent to NQ. Since MN is doing the bisecting and is not the one being bisected, we do not know if it's congruent. Now, that doesn't mean that it's not, so we can't be definite. This is not necessarily true. Therefore, this would be a sometimes. Now we come to our second definition, trisect. Just like bisect, trisect is very similar. What a trisecting segment or point does is it is 2 points, segments, rays, or lines that divide a segment into 3 congruent parts. If we look in the second example, it says, if point E and F trisect line segment DG, what can we conclude? Well, based on the definition of what trisect means, we can conclude that DE is congruent to EF, which is congruent to FG. We can also come to the conclusion that line segments HE and HF are trisectors of DG as well, since they connect to the points that trisect. The segments themselves will trisect line segment DG. But what about the angles? Is angle DHE, EHF, and FHG congruent? Just by looking at this diagram up on top, it does appear that these would be congruent. They look very similar. But since the diagram does not show that, we do not know that. Think about this diagram. We could actually take this triangle and manipulate the point of H, bringing it maybe closer and above point D. Now, points E and F still trisect line segment DG, but you can see that the angles now in here are different than they would be up here. Therefore, we don't know if these would be congruent. Therefore, it would be a sometimes. What do you think it means to be an angle bisector or angle trisector? Well, very similar to what it means to be just a midpoint or a trisect point. A bisector is a ray that divides an angle into two congruent parts. While a trisector is two rays that divide an angle into three congruent angles. In our third example, it asks us to draw a sketch for the statement AB and AC, where each bisect angle DAE. Well, let's start by drawing the angle DAE. As you can see, they need to share the same point A, and they need to be rays. So what we're going to do is we're going to start with AB and draw it so it bisects the angle, making two congruent parts. But we also need AC to do this. Now we can do this in one of two ways. We can make AC come the other direction, where it bisects on the other side. Or you could put the point on the same ray where they overlap, as it still creates congruent angles. Finally, let's end with a quick proof. We're going to do another two-column proof using our statement and reason approach. What's given to us is that line segment DE bisects line segment AC. And what we want to prove is that AB is congruent to BC. Again, what you'll find in these beginning sections are that the proofs are very quick and usually straightforward, letting you get the hang of the format and how to write a proof. We, again, start usually with our statements. DE bisects AC. And again, our reason is just simply given. Now let's think about this. DE bisects AC. And what we know about bisecting is that it creates congruent parts. So if we look at AC right here, we know it's going to be divided into two congruent parts. Therefore, it goes right to the proof of AB is congruent to BC. And the reason for this is if a segment bisects another segment, then it creates two congruent segments. Again, this is the definition of what bisecting is. But again, I would like you to write it out as this format with the if-then statements. Once we get into more complex theorems, you'll see why that's more important than just writing a definition.